In this video, I want to show you how to convert the procedural displacement in your cycles shaders into real geometric displacement. So if we take this scene, for example, it comes from a recent course I did about generating procedural sand dunes. And we have the shader network on the left. And then down here, you can see that the geometry starts from a flat plane. However, if we look at the rendered view, that flat plane has become realistic sand dunes. And this kind of displaced geometry is only accessible at render time. We can't edit it as if it's a real model. But with the technique I'm about to show you, it can be converted with near perfect accuracy. But first I want to give a shout out to the CG Cookie member who discovered this technique. And it started in this thread with Emirqua, who baked out the displacement data into a regular image that achieved an okay displacement, as you can see on the right, but it's not exactly like the shader version. So there's a disconnect in the conversion. And the reason for this is that in the shader displaced version, the geometry is not only being pushed along the mesh normal, in other words, being pushed up for this flat plane, it actually is pushed out at an angle. But a regular image in the displacement modifier is not going to make this happen. And so Ian Johnson discovered a better method that results in near perfect accuracy that I'm showing you in this video. So thank you, Ian. I think a lot of people are going to find this useful. Okay, so back in Blender, the core idea of this technique is to bake out the displacement data, which is coming from this multiply node here. And in order to bake it out, I'm going to turn off our subdivision. We don't need that for this task, nor do I need it plugged into the displacement socket. Instead, let's just look at it by Shift-Control clicking on it. And we can see that the data is mostly white. And the reason is because I'm multiplying the value by 15. If we take that down to 1, we get a much more clear idea of what the values look like and how they result in the sand dune shapes. However, I want this to be as accurate as possible, so I'm cranking it up to 15, which means we can no longer use 8-bit image data. As Ian discovered, we need to bake this data out using 32-bit float. So for the baking process, I need an image texture to bake to. So I'm going to add texture, image texture. Let's create a new one. I'm going to make sure that 32-bit is enabled. And since I want to maximize the accuracy of the displacement, I'm going to bake out a very large map, 8K, so 8192 by 8192. It means that the bake data will be pretty big. I'm expecting about a gigabyte for the single image. But again, it will ensure maximum accuracy. And I'm going to call this bake displacement, or just disp for short. Okay, let's create that image. And since this object started out as a plane, if I tab into edit mode, you can see that we already have the UVs laid out by default. But in order to bake, you do need UVs specified. Now that this is confirmed, I'm ready to bake. Now, some important settings. If we go to the render panel up at the top, make sure that I have cycles enabled. Sampling, I'm going to turn down to 1. Because it is pure color information, we don't need more samples than that. Also, in performance, under the tiles, make sure that this is set to the dimensions of your image. So 8192 by 8192. This will drastically reduce the bake time with cycles. And then finally, we can go to the bake settings themselves. Make sure that I am using the emit bake type. And the reason for that is, remember, I'm plugging that displacement data into an emission node via the Node Wrangler add-on. And then last thing I need to check is to make sure that my bake displacement image texture is selected. In the shader editor, go back to UV editor, and I can bake this. And there we go. It did not take long, even for such a big map. Now, when you see this color information, you might think all the details gone, it's completely washed out. But remember that that data is being saved in the 32-bit float depth. So if I save the image as an open EXR, make sure to choose 32-bit float, and I'm going to overwrite this previous version. And you can see that it is in fact a gigabyte, but it's a temporary file. As soon as we get the geometry displaced, we can delete that file. And now I can jump back into the 3D viewport. I'll pause the rendering for a second, and let's set up our modifiers. We already have a subdivision surface which comes from the project that was using adaptive subdivision. And this is where you control exactly how detailed the displacement is going to be. 4 levels is a little bit low. I recommend probably 5 or maybe even 6. Basically, if you see a sort of pixelation happening in the geometry, then you can increase that level. I'll go with 5 just for the sake of recording because level 6 does get pretty slow. So we've got 5 levels in the viewport. I'm also going to make the render levels 5 as well. And then we can add our displace modifier. And we'll need to create a new texture. I'll call this true displacement. And let's go find that in the texture properties. Let's load that file that we saved. And this really doesn't look like what we were expecting. That's because we need to set the texture coordinates to UV. And then finally make sure that our subdivision is working in the viewport. And there we go. That looks pretty good. But we want to confirm that this is in fact very close to the rendered version. So in my 3D view, if we turn off the pause button and look in the camera view, oh, also I need to change the shader to make sure that we're seeing the principled BSDF instead of the displacement output. And oh, I almost forgot a very important setting. Now this looks pretty good, but if you remember, the actual render did not look like this exactly. And that's because the direction here is very important. We need to change that to RGB to XYZ. Now when I select that, this looks almost identical to the shader-based displacement. So to test out the accuracy, let's go back to our render settings and update them for actually rendering, not just for baking. So 64 samples, the tiles can be 64 by 64. And then I will use GPU compute and go back to our modifiers and make sure that the subdivision is enabled for rendering. And let's render it. If I look in slot 1, this is the shader version, and then slot 2 is the geometry version. So this is the shader, and this is the geometry. You can see that it's really close, but it looks like the camera has sort of shifted. It just means that there's a slight discrepancy in the displacement values. So, I mean, we can try and get closer. I think to me, if I go back and forth, it looks like it's just a little bit stronger in the shader version. So perhaps in the strength of the displacement modifier, I can go up to like 1.1. And then let's see if that helps. Slot 2, let's render it. See the before and after. And yeah, this is really, really close. And personally, I don't care that it's not exact. Getting this accurate at all is really exciting. Because now I have an actual geometric object that I can decimate, for example, and use as a game environment or something. Whatever you would need to do with an actual model. So let's add a decimate modifier. Take the ratio down to 0.1. And though I skipped ahead in the video, that did take a solid like 20 to 30 seconds to calculate. Then I would convert to a mesh to essentially collapse all of my modifiers. And that actually took about 45 to 60 seconds. But at this point, I've got a true geometric version of our procedural displacement that I can edit as a mesh and do whatever I want to. It's a pretty amazing technique. I've been wanting this functionality for a while. So again, thank you, Ian. And if you want to see the entire sand dunes tutorial, you can find that on cgcookie.com.